So dear children, it is important at the very onset that you breed some familiarity with three basic terms. One is an expression. The first one is an expression. Now, what's an expression? An algebraic expression. When I'm talking of an expression, I actually mean an algebraic expression. Something like this, for example, x plus 1 is an expression in x. It's a linear expression in x, right? For different values of x, this expression will assume different values. Then there is something like 2x squared plus x plus 2. This is also an expression. It has no intelligence of its own, but different values would be assumed by this expression in general for different values of x. This expression, in which the highest power of x is 2, is a quadratic expression. Then we could have had an expression like this, for example, x squared y plus xy squared plus x plus 1. This is an expression in x and y. For different values of x and y, this expression will assume different values, right? Now, suppose I refer to an expression as f of x. It means it's an expression in x. It's an expression in x. Now, f of x, let's say an expression in x could be, say, for example, x cubed plus x plus 1. This is an expression in x. F of x means I'm talking of an expression in x. Now, f of 1 would mean the value of this expression at x equal to 1. So the value of this expression at x equal to 1, put x equal to 1 in this, 1 cube plus 1 plus 1. 1 cube plus 1 plus 1. That makes it 3, right? Say, if I write f of 0 means the value of this expression at x equal to 0, which is like 0 cubed plus 0 plus 1, 0 cubed plus 0 plus 1, that makes it 1, and so on and so forth, right? This, for example, is an expression in x and y. You could write this as f of x comma y. F of x comma y, for example, is an expression in x and y. F of 1 comma 0 would mean what? In this expression, replace x by 1 and y by 0. Replace x by 1 and y by 0. So replace x by 1 and y by 0. You would get f of 1 comma 0, right? That is what an expression means, right? It's in a certain sense a dumb algebraic entity. It's a dumb algebraic entity. Now, the second thing that you want to understand is what is referred to as an equation. Now, an equation is essentially an algebraic statement. But that algebraic statement should be true only for certain set of values. For example, an algebraic statement could be x plus 2 equal to 5. This is an algebraic statement. And it is true not for all values of x. This algebraic statement is true not for all values of x. It's true only for x equal to 3, for example. It's true only for x equal to 3, for example. Right? 5 minus 2. So that's an equation. An equation is an algebraic statement which is true only for certain set of values of the algebraic variable. In this case, x is said to be the algebraic variable. So it's true only for x equal to 3, for example. I could have had, say, x minus 1 whole square equal to 0. This also is an equation. This also is an equation. And it's not true for all values of x. It's true only if x is equal to 1. This statement is true only for x equal to 1. That's an algebraic equation. Something like 2x squared plus x minus 1 equal to 0 is an algebraic statement true only for certain set of values of x, right? And therefore this also is an equation. right? Now, the third terminology with which you must breed familiarity is an identity. Again, it's an algebraic statement. An identity is also an algebraic statement. But that algebraic statement will be true for all values of the algebraic entity. For example, x in the earlier cases was an algebraic entity. So, for example, if I write x square minus 1 equal to x plus 1 into x minus 1, right? You've learned how to factorize x square minus 1. It's x plus 1 into x minus 1. Now, this statement is true for all values of x, whether you plug in x equal to 0 or x equal to 1 or x equal to 2 or x equal to minus 1. This statement would be unconditionally true for all values of the algebraic entity x here. And such a statement is referred to as an identity, right? So an identity also is an algebraic statement, unconditionally true for all values of the algebraic entity. In this case, x is the algebraic entity, right? So this then should bring to us an understanding and distinction across these three terms: expressions, equations, and identity, right? I hope by this time all of you understand very clearly all the three terms involved here. Thank you so much.